Hello everyone and welcome back to TritonTv. Today we are going to be looking at this toolpath right here called Unified Morph. It's quickly becoming one of my favorite multi-axis toolpaths. So I just want to talk about the setup we have here, some of the settings in the toolpath, and the cool things about this toolpath. So I'm just going to go ahead and play it in backplot. And in my last Mastercam video that I made, I didn't say anything, I just did some video, but we'll go ahead and start the sim as well. So I'll go ahead and start backplot here, and we'll cycle through once, come down, cycle through. I changed a few settings since I recorded that. So there's a setting in here. I'll just play through it and we'll kind of check it out. It's a really cool toolpath. In this instance, I'm tilting away from the wall. I'll show you exactly how I did that. And we're also avoiding the vise here, but I noticed that I needed to move the vise down 15 thou in order to correlate with how the part would actually be inside the vise. And I'll show you those numbers here in a second here. Let's toolpath finish. So you can see a nice smooth motion coming from the top to bottom. You could argue starting on the bottom is better. This would just be the finishing of those fillets. And this material would be aluminum, so I'm not really worried about quote unquote cutting on the tip. So one thing I'll show you just real quick, if we analyze from the bottom of the vise here up to the top, you'll see 1.735. I pull up my calculator here, type in that number, 1.735 minus 1.625, which is 1 5/8 parallels. We'd be holding on to 110 thou. So if I go here and I look at the bottom of the part to the top, I know there's a chamfer, but look at that. Hold on a second here. I'm confusing myself with these numbers. So we needed to measure from here to here. So, oops, we need to measure from here to here. Oh, I think I might have been dyslexic. You get the point. 1.375. Why am I getting confused here? We need to measure from here to there, 1.735. And I think, yeah, okay, I subtracted the wrong number. 1.735. Since we have a 1/4 inch radius, I believe I picked the size that would be, quote unquote, if this was square edges, 3/8 of an inch holding onto the part. So 1 5/8 would be 1/8 of an inch holding onto the part. We need a 1/4 inch shorter than that. So let's just type that in 1.625 minus 250. Yeah. 1 and 3/8 would be the size of parallels that we would be using, which would leave us holding on to roughly 360. And like I said, so if we come down here, measure up here. Oh, measured from the wrong spot. This is turning into a disaster. Yeah, so 1.375 would be the size of the parallels, and that would get us roughly 110 thou. That's the number I was getting. 110 thou of the part where these two tangencies of these arcs, which they're in line, would be below the vise. And so before that was 15 thou taller or something like that. Didn't mean to spend that much time on that. But anyway, this is the setup of the part. I moved it down. I noticed in the last video I was only 10 thou away from the vise. It's supposed to be about 20, 25 or whatever. So anyway, so one thing I'll talk about is I made a stock model that takes into account this stock model as the starting condition, and then these toolpaths here minus that guy would be what this stock model was made to. So it starts here, it runs all these toolpaths, and then this is, I have my toolpath display off by default. I don't like seeing the toolpaths unless I'm running backplot. I know that's blasphemy, but that's just the way I like it. So I will go ahead and push Control T, does different things depending on if you're in the graphics window or if you're in here in the toolpath manager in your operations. So if I have a operation selected and my mouse is somewhere in the toolpath manager, if I push Control T, it's going to, I think I need to have this on. Yeah, so it's going to display the toolpaths. Now there's also Alt T out in the graphics window, which will turn on or off. However, since this is restricted to only that one, it's only going to show that. So if I push, oh gosh, this is so picky. So if I push Control T here, turn that off, Alt T up here. Of course it acts funny. This has always been kind of bugged. Whatever. You get the point. This gray thing here is the stock model after all of these. Oh, there we go. That's why it's doing that. That makes sense. I'm not used to having this setting on. I hate toolpaths. There we go. There we go. So now we have restrict display only selected toolpaths on, and then when I push, yeah, so when we click on a thing, it'll show the toolpath. I don't like that, so I come out here, push Alt T, but when I click on the stock model, for some reason, that's the one toolpath that will still display with Alt T. It's such a weird modality between toolpaths being on and off. I guess stock models, I don't know, have a high priority. Sorry to go off on all these tangents. Anyway, that is the condition that I start with this toolpath. So I'm going to go ahead and turn this bad boy off again by pushing Control T. And also when I click on toolpaths, they're gone. So if we go into the Unified Morph toolpath and we click on the parameters, I'm going to show you. So we have our tool selected. We got our speeds and feeds, blah, 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 comment. I have a holder with a certain stick out. This is actually, I just picked a holder. This holder actually looks like it's too big for this machine that I have selected, but whatever. I don't care about that. So I'll go ahead and scoot this over up in the corner here. I'll zoom out a little, and you can kind of see any multi-axis toolpath or some 3D toolpaths will color code things once you're in the geometry menu. And so we'll make note of a few things. So the machining geometries I picked, I just wanted these surfaces down here. So I went ahead and picked those. And I gave it morph curves. If you're unfamiliar with what morph curve actually means, I think there's like, I don't know, this mysticism of what it basically just means you're taking the toolpath and you're starting with, in this instance, the blue curve. You're ending with the yellow curve. You are morphing how the tool goes along your machining geometries, or drive surfaces as a lot of the surfacing toolpaths call it. You're morphing the toolpath from here down to there. So you're basically taking this curve and eventually ending up with that curve. And so from the top, what you end up with is a nice toolpath that blends in with the shape of the top curve and the bottom, is basically what Morph toolpath does. So anyway, I'll turn the holder back on. We'll go back into the parameters here. So as you can see, we'll go back to the cut pattern. So we have our geometry here. And then there's a few settings on here. We're just doing a spiral, which will get you a nice smooth toolpath. As long as you get everything right and it's reading the surface well, it should get you a nice smooth motion. What is the other toolpath? Waterline will also do that, and equal scallop if you get everything right. Sometimes surfaces and solids get red weird. So anyway, this is the default, I think. NX calls this in tall and out tall. This is just our, basically a profile, if you will, of 1 thou is what the tool is allowed to follow this surface. And I think I gave it a step over of 20. I played around with the step over. I like these toolpaths because they update live. So if you enter 25, it updates the scallop, which is pretty cool. And that's a relationship between the step over and the radius of the tool. So anyway, we're gonna have a 4/10 scallop. We're doing spiral. And then now we'll get into some of the funner stuff. So let's see here. This is the setting that I changed to get the tool to actually do climb cutting all the way around the part. Depending on how it reads the surface and the concavity and convexity, convexness, however you would say that, it'll generate a toolpath in a direction, and if you turn this on, it'll actually look at where the tool is contacting the part and what direction it needs to move in order to be climb cutting or conventional cutting, depending on what you told it here. So I told it climb cutting here. I didn't mess with too many of these. This is the default, I think. I think this is the default, blah, 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 blah. These are all defaults. Now we're getting into the interesting stuff. So we're outputting 5-axis movements. Angle step is 3, meaning the max change between motions would be 3 degrees. And this is the kicker here. Tool axis control. There's tons of settings here. Surface is kind of like normal to a surface at the point at which it's at. Surface with tilt, you can give it tilt. Angle towards tilt axis, you can give it an angle and tell which axis to tilt towards, depending on if you're on an A axis or B axis machine. That would make sense there. Fixed angle to axis, I don't know if I've messed with that one, but the one that we used, I'm going to exit out and come back in just so I haven't changed anything. The one that we used is from 2-point. So 2-point is a really cool setting. To and from are pretty cool. So as you can see by the graphics here, the spindle orientation will be pointed straight at the point when you're going to point. From point is the exact opposite, right? You are the top of the spindle is pointing up towards. So in order to get what you want on that one, let me think about this. I don't know if you can get it. Yeah, like this point here when I'm doing 2-point, I don't think you can do it with from point because it would basically be a chain like this out in space. So not one single point would get you the axis that you wanted. So 2-point was the thing that I tried here. And I think initially I had selected this point, which is 2 inches. I just picked a number. I went to create point position, and not sure if many people know this still, but if you start typing in numbers in pretty much any create geometry function, it'll automatically, this is old school Mastercam. It's kind of like AutoCAD. If I type in 0, 0, and then minus 3.333, it's going to place a point at that position and whatnot. So it's a really quick way to create geometry. And that's what I did. I just picked 2 inches at first, ran the toolpath. And then I actually wanted the tool. Let's think about this here. So if our point is closer to the part, the angle orientation of the tool will be, let's see, either closer to the part or further away. Let's think about this. Let's look at the part. Actually, let's do this. Let's just look at the solid and these 2 points. Okay, so let's see. If we look at the point, orthogonal, if you will, let's do this, to the part. This would be our axis at this point, and then we basically would be looking at it. So if the point goes further away, let's see. We're actually tilting towards the part. Yeah. Anyway, so I played with that and got the angle that I wanted. Yeah, and in this instance, we don't have a tilt angle. I think this, yeah, this machine is an A-axis machine, so this is probably set wrong, but there's no tilt, so we're not gonna worry about it. Limits are pretty cool. I've messed around with limits in Unified. If you just kind of know what you're comfortable with, if you're in a B-axis machine, I believe, yeah, it would be this one here, and you can click on it and it'll kind of show Z is up in that direction, X is here. You can limit it, you know, and I did set numbers here, but we have it off. So these are the numbers that I was comfortable with. Comes in handy when you're trying to avoid things, and you can basically get the toolpath to avoid things just based off of where you limit the angle. This is default settings, I believe. Collision control, this is where you get into some of the settings that will help trim the toolpath or tilt the tool, depending on what you tell it to do. In this instance, I got lucky, although we do have these set. So you can see the machining geometries in green. And then the avoidance geometries are in red. Basically, I just wanted to avoid the top of the vise and then the sides, depending on how far we got tilted there. And this boss as well. I don't think with the way we did from point, I don't think we'd actually get an angle to where we would touch this. However, it's nice to pick vertical things that would be in the way of the toolpath, and you can get the toolpath to tilt. So you can just tilt. In this instance, I left it on trim and relink. So you'll see if you get a bunch of relinked motions, you'll know that this has been active in your toolpath. Some settings here: 0.1 from the holder, 0.025 from the shank, 0.01 from the shoulder. And then this is kind of cool. You can just say, hey, instead of all this crap, I just need an angular clearance. Actually, I think it works in conjunction with these two. A lot of settings in this toolpath. So there's other things you can do here. Let's see, I think I left these on default. Get a nice lead in, lead out. These can come in handy, like if there are a bunch of retracts, you can set, I'm thinking of a different toolpath, where you can set the like linking shape to sphere or whatever. Where is this at here? Yeah, I'm thinking of, I think one of the other tools, swarf is what I'm thinking of. So anyway, that's basically what I did with this toolpath. Was I selected the faces that I wanted to cut, and then I gave it these nice morph curves. It was spitting out a decent tool. It'll, instead of calling it unified morph, this toolpath is basically a conjunction of multiple toolpaths between morph, project, guide, and I think there's one or two others, flow. It's like all those toolpaths in one. If you don't have anything selected up here, it's going to call the toolpath unified automatic, and then it'll do automatic strategies for how to blend the curve. So there's instances where you probably end up with the exact same toolpath by selecting different things depending on how you tell it to do the axis of the tool. I thought I gave it this stock, but I guess not. The main benefit of having a stock model right before this toolpath is I can do something like this. I can go into my levels manager and just turn on the solid and the geometry, turn off the vise, turn off the surfaces that I drew. And then there's two ways to get into the settings that I'm going to show you now. You can either go to Files, and it's going to open up the menu with like stock setup, let's see, machine, master model, stock setup, work holding tools, and simulation, or I can go to machine and click on simulator. And this will take me straight to the machine sim page, but it's down here, so you'd get there anyway. So in this instance, we have the default Hermely machine selected. And just one thing to note, there's a pretty good naming convention on. So we have vertical milling center. And then we have AC for an A axis and C axis machine. So these things do follow a convention. Yeah. Anyway, that's the machine we have selected. And then the other thing to note here is I actually did have to move the part to get it to simulate properly. And that's something that takes a little tinkering with. And what that has to do with is typically it has to do with the orientation of your machining plane that you choose. And in this instance, I'm using a custom plane that I called boss. I'll go ahead and select all of the planes that I have created. Actually, we're going to turn off the bolt ones because those are for the bolt. So you can see these planes here. And then if I click Alt, or if I click F9, you can see where the top plane is and this other plane. So let's go ahead and go to the top plane here. So yeah, you can see the top plane is actually orientated 180 degrees about Y, I guess you could say, or X. The part is rotated completely around. And it's also translated some distance in Z, which is 450 thou. So if I go to our boss off plane and look at the part, you can see our Z is 450. Now let's go back to the sim. This is something that drives me crazy at work and here. Sometimes you just have to play with it, and sometimes it doesn't make logical sense. It has to do with how this machine is set up, and I think since we don't have the right machine definition and whatnot is also part of the problem here. So anyway, I'll show you what this looks like in the sim. So I'm just going to have my model and wireframe geometry selected. One more thing, actually. So in the work holding tab, I have my level 31 vice setup, and you can see it's the Op2 Kurt DX6 vice. So we have that selected. So there's a button in the simulator that'll turn this on and off, and it actually won't be checking, it won't be making like a, when verify runs, it makes like a 3D representation of the toolpath, and where it's removed stock in NX, it's called the IPW. It doesn't do something like that. It just is for visual representation and crash simulation. So yeah, so we have that all set up. Let's go ahead and jump into the simulator. I know this is kind of all over the place, but this is kind of how programming works. You think of things and do things in a setup. Oh, sorry, one more thing. I swear. So at this instance, my stock setup is actually a mesh, and you can see it on screen now. And what this mesh is this mesh was actually created from, yeah, so this mesh was created from, I'll show you here. Let's see, you start with this stock model, and then you run these toolpaths. And then when you do stock model, you can, I can't remember. I created a mesh based off of this stock model though. I'm trying to think of how I did that actually. Let's see. Up on source. Give me a second here. Up to stock. I don't think it's a real entity. Like it's not in my levels list. Yeah, this is, I'm getting things mixed up between different softwares right now. So yeah, this mesh here was created from, let's see if I can remember where I did this. Add from a selection. I don't remember how I did this, but I created it from that stock model setup is how I got that. Because like this stock model, let's see, let's do this, is not selectable, right? Because the stock model is actually a toolpath. So I can select the part and the wireframe, but this thing is not selectable. So you can make it in the stock setup. But anyway, that's, when you go back to stock setup, you can click on different stock models and solid models that you've made for stock, and you can make them the active ones. So in this instance, now that I've gone through those toolpaths, I made this mesh the active thing. Yeah, it's basically a ghost entity. It's not a real thing. I'll have to think about how I made that. So anyway, when we run our, let's go into the simulator here. So when we run our sim, in this instance, it's going to start and verify, which is very similar to the sim, except it's not going to, you know, pull in the machine and all that stuff. You can see our initial stock setup is with, it's that same as the stock model, right? And then our workpiece is still under there, under the part. I think the colors are doing something weird right now. I don't know if this should be red. Anyway, so we're going to turn on the stock, and then we're going to, I'll just run it real quick through verify. There we go. If I want to compare, I'll click on compare, run that with tolerances that I've set, and then you can see we've machined all the green stuff, and we still have this pocket here and this threaded hole on the side of the part. So I'm gonna go ahead and turn off compare. And now we can go to the sim. And so this is where that tweaking with the position of the part will come in handy. And it's a little bit easier when you pick like a normal toolpath. But once you get it right, it works for all the toolpaths in that setup. So, you know, I think I used this initial toolpath here to get this figured out. So go ahead and pull this guy back up. So you have to tweak with getting your fixturing and whatnot where it needs to be on the machine. And one cool thing that I've learned, recently is you can actually measure inside of the simulator. So you can be like, oh, I want to know what is the distance from here to there, and with this axis aligned feature, you can check things. And the cool thing about it is if it's from something fixed or moving on the machine or the part or the fixture to a tool, when you step through, it will actually update on the fly these values here. It looks like our X and Y aren't moving, but our Z is moving. Pretty cool. And then once you want to get rid of it up here, you can click on clear all. So yeah, we'll just go ahead and step through this. I'll slow it down a little bit. And there's so many cool things that you can do that I don't think a lot of people take advantage of. Like, you can do this, but you can come over here and be like, oh, I want to see what it looks like when I move the Z value up, however much, or the Y value over here, or X, whatever. And then when I click S, it's going to step through and automatically move the tool back to exactly where it was. So there's a lot of really cool things you can do with the simulator as far as, you could see this number here. I think it'll let you edit these. And then let's say I wanted to add -10 to that. So 84. I think it's right here. Yeah. So if I hit enter, it'll move that axis. So if you're checking for collisions and whatnot, you can come in here and manually type in a number. And yeah, and there's different settings for the increments and whatnot. Really cool settings in the sim that I don't think a lot of people actually take advantage of, that can really help you with your verification of crazy toolpaths. Like right now at work, I'm working on a part that has lathing and multi-axis toolpaths all in one. So I have a lathe machine group and a mill machine group and different stock setups for each and all this crap. And so I've been learning really cool stuff about the simulator here. What else is a cool thing? Yeah, so compare. We already know how to use that. That'll also turn on when you click this. You can see compare is turned on. So let's turn that off. And the toolpath analysis is pretty cool. So if I turn the toolpath on, hopefully it behaves. It was acting weird. Yeah, so we can see the few lines that we've drawn on the toolpath here. We're following the tool, so we're only drawing from the start to where we are. So if I like step through a little bit, you can see more of the toolpath there. Let's let it do like one full rotation here. Okay, so we'll stop it there. So when you add a filter to the toolpath analysis, it will go ahead and color the toolpath. So if I had all my toolpaths right now and I clicked on operation, and this is the operation that we're running, you have all these different options for the colors. It's pretty cool. So I don't know if you needed to look at this, but you can also look at tools as a filter. Feed rate's pretty neat. It'll tell you if it's cutting motion or rapid retract. So if I go all the way through, let's let it get through. I don't know if it's working right now. Whatever. You see the difference here. Segment length, blah, 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 blah. All kinds of cool little filters you can add to that. So if it turns toolpath off, get out of the toolpath analysis. Let's see. In my last video I showed, I turned this two views on. and each view is modal, so I can move this, come over here, move that, come over here, move this, and they're going to be updated when the tool moves. We're at the end of the toolpath. So yeah, you can see like you can do all kinds of cool stuff. You can do 4 views, you know. I don't know if you're like really trying to look at stuff, and each one of these has its own like, I think you can measure inside of each one of these. Yeah. Oh yeah, that's cool. It highlights in all of them. So like there's a lot of really cool stuff you can do with the simulator as far as double checking things. But that gets a little busy really quick. A couple more things. Let's turn off this distance thing. I don't want to measure here. We'll do this. There we go. We'll just clear that. Let's see here. So view, this is kind of cool. Typically when you have, you know, a setup with a bunch of things, you're going to be in this multiple workpiece view. So if I click Alt and 1 to go to my top view, you'll notice we're actually at the bottom of the part, and I think that's because the initial setup, yeah, the initial top view was facing the other direction. But if we go to workpiece and I click Alt plus T, it's actually going to give me the perpendicular top view in relation to where we are. So if I step through, we're already at the end of the toolpath, or no. Yeah, this gets weird quick, so let's slow this down. So if I, if we're in the workpiece view and you let it run through a toolpath, the view is as if the workpiece isn't moving and everything else is moving around it. It's really weird. It can kind of help you get your bearings initially, but it's not reality. So I don't like that one. And then the tool, you know, is very similar, where it'll basically be a nice view in relation to the tool. You know, you can kind of see like if I set it, it's going to be basically the same as the multiple workpiece, but in relation to the tool. So a little bit of differences there. Yeah, there's all kinds of stuff over here. You can look at some code and whatnot. Let's see here. Yeah, so you can see our live X, Y, Z, C, A directions here. Operation comment, blah, 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 blah. So I just wanted to show some cool stuff with this toolpath, the simulator, just kind of test out my new setup with the microphone and whatnot. I believe that the Mastercam simulator or any 3D machine sim of toolpaths comes in really, really handy when it comes to these cool toolpaths where you're moving the tool in all kinds of directions. Because if I get out of the sim and I click on this toolpath and just let it run through, you can see that all we're seeing is how the tool moves in relation to the part, right? Because our view, our perspective isn't changing, the tool is changing, right? So sometimes it's hard to wrap your head around like what the machine is actually going to do with some of these crazy toolpaths. And in this instance, Unified is just like really cool toolpath that has a bunch of different functionality. So yeah, just kind of wanted to talk about this toolpath, talk about the simulator, show some settings. Yeah, we'll zoom out here and we'll actually we'll go back here and turn on the op2 vice, and then I'll show you op1 vice, blah, blah, blah. And that's actually the reason why op1 and op2 are in different machine groups. It allows you to get different setups with different fixturing and whatnot. And that's where the need for stock models kind of came in. I avoid them unless if I really need them, but in this instance, if you're doing this, you kind of need them to start with where you left off without having to draw all this custom stuff. And then I'll show you an op3 setup that I was working on and programmed, which will be maybe one of the next videos. So we're going to turn off op1 and op2 vice. We're going to come over to op3. Op3 is actually the bolt. So we're going to turn on the bolt here, bolt geometry, bolt solid, turn off this and that. And then I downloaded a 5C collet block. And we're going to go ahead and turn on the planes for this. So it's going to be bolt WCS and bolt top. This is a good time to talk about 3+2 planes and whatnot. So if we look at the bolt WCS, this is kind of how you'd set it up in the machine. You know, in this instance, I have the 5C collet clamped right there and the parts sticking out over here. We'll turn on the bolt stock. So this was an actual part that I made, and I did modify both the bolt and the handle. The handle was made from scratch, and the bolt was just a modified bolt that came with my 5-axis mill stop. So yeah, this is how I would set this work offset in the machine. Maybe I can move my Z up, probe here, whatever, but just to kind of show you what this looks like. Turn off the bolt stock here. And yeah, so now I'll turn on the rotated plane. And it's rotated in a certain way. I try to make my 3+2 planes rotated in such a way that they're actually how the machine's going to look. So in this instance, I believe A on this machine would be positive. I think so. So anyway, I rotate it to where the y-axis would be pointing in y in the machine and the x would be pointed in x in the machine. You don't have to. Post-processors and the machine control will take care of the kinematics there. I just like doing that because it helps me get a better understanding of what things are going to look like. So we're going to go ahead and turn this plane on. And we're going to go to the op3 bolt. And I just wanted to show you setup there. And I'm going to go ahead and turn off the 5C collet block and the vise because they're already selected, which I'll show you now. Same thing, I had to move this setup as well, I believe. So we go to the stock setup. It's the, you can kind of see the red outline here. It's that solid that I showed you. And then in the work holding tab, we're using both of these. Yeah, I think it's going to show them both. Yeah, I believe so. I believe so. And then I had to play with the X and Y values. And a lot of times when these rotated planes, they're not the direction you think it is. Yeah, actually I had to move X, Y, and Z to get the vise where I wanted it to be. So that's where the measuring in the sim comes in handy. So we're going to go ahead and step through these operations real quick. And just, yeah. So this is verify. I'll just let it run verify real quick. Just like a little hex cutting there, chamfering, and that's it. Just a real simple op is really all it was. Yeah, so we're gonna go ahead and go to the sim and just show how this would actually look in the machine if we had that same vise, you know, and 3+2 stuff when you're doing stuff off the side of the vise. It's kind of nice to get it a little bit away from the vise. And I think I even grabbed a longer tool just to give myself more clearance here. So yeah, over on the right, you can see we're at some XYZ value. Yeah, so this is a positive. A good way to think about it is if you look, I guess, from the positive to the negative of an axis. Let's go ahead and turn this off. So I'm looking, we're looking from the positive X to the negative X direction. The tool has had to rotate around the part in a clockwise direction, or the other way to phrase that is the table has rotated counterclockwise to get the tool to rotate clockwise around the part. And that's why this is actually positive A. It's one of those things with 5-axis that kind of confuses you when you actually really start to think about it and understand it. On most machines that I've ran, the direction the table rotates is actually backwards of how the tool ends up. And that's why the numbers make sense in the code, because the code cares about the tool, not the part. So like one thing that I remember, one of the guys who set up a DMG machine, he was like, yeah, don't think about what the machine has to do to get there. Just think about where your tool's moving. I might have said that backwards, but you get the point. So let's go ahead and step through this, and then I think that's going to be about it for this video. Just kind of want to talk about Unified, talk about the sim, talk about some setups and whatnot. So we'll go ahead and step through here, turn the housing back on, maybe make it translucent. And we'll just run through that, do 2D high speed, I believe. And then this would be a finishing of the hex. And then we got a little chamfer here. Boom. And that would be op 1 and 2 done for my part. And yeah, the bolt here. So I'm going to kill this, pull back up the part, solid geometry. Let's go ahead and pull up op 1 maybe. And then let's pull up our op 1 plane and our, maybe our op 1 stock wire. Boom. Oh, that's where it is. This is that mesh. I don't know if you remember when I was talking about my stock setup for this mesh, this weird green thing is very similar to an STL. It's like just a bunch of triangles. But this mesh was created from this stock model. Pretty cool. So yeah, there's this mesh. I don't know much about meshes, but I think STLs create meshes, I guess would be a way to say it, or an STL is meshes. But anyway, I've kind of rambled on for long enough. I know this is kind of all over the place, but there's a lot to this software. There's a lot to multi-axis machining, and there's a lot to verification. You know what? We're going to create a new level. This is driving me nuts. We're going to create 8. We're going to call it up to stock mesh, and then I'll call it SM2. So it's stock model 2. And then this is going to be our main level. And what I'm going to do is select the mesh, right click, come over here, move it to the main level. Boom. So now I can turn this level off and I have exactly what I want. So this was the initial setup. Screw it, I'll talk about this too. So this was a 1 5/8 parallel, which would leave us holding on to 110. Yeah, I'll talk about this part more in detail and what it actually is and actually show it to you in a real video. But that's probably going to be it. This video is long enough for sure by now. So yeah, hopefully anybody who programs machining, or even if you don't program machines, you find this interesting. There's a lot that goes on in making parts, and we're expected to be like really fast at doing this and setting all this up. And that's why my right click menu has all kinds of cool stuff that I use all the time that I don't have to go sorting through up here. So anyway, that's gonna be all for this video. Hopefully you enjoyed it. If you're not in manufacturing, and if you're in manufacturing, you should stick around. I will definitely take requests on milling and lathe setups. I have this educational version on my computer. You can't spit out code, but it does have milling, lathe, mill turn, wire, router, design, blah, blah, blah. It has all the stuff, so I can maybe talk about creating tool managers and this and that. Yeah, and just, I guess as a side note, I've been programming CNCs for about 13 years now. I've been using Mastercam the entire time, so I'm pretty familiar with the software and the changes over time. I like it. I think it's great software. It's got its bugs, it's got its nuances, but it's efficient at doing what it has to do. And toolpaths like uniform and flow and all these other things are kind of another beast that you just end up having to tackle, So yeah, that's gonna be it. I'm trying to find a good spot to save this at. Let's see here. Let's just leave it like that. We'll go ahead and save it there. And that is gonna be it for TritonTv on some Mastercam talking points and whatnot. Leave a comment below if you program CNCs and you think this is cool, or you think I'm a noob, or whatever it is. If you don't program CNCs and you thought this is boring, you should just smash the like button anyway. And subscribe to, yeah, watch me lose my mind on 3D models and machining. That'll be it. It's TritonTv, over and out. Have a good one. See you, bye.